Welcome back to the Network Plus training series. In this lesson, we are covering Objective 1.5, Compare and Contrast Transmission Media and Transceivers. Understanding the physical media that carries network traffic is essential for any network professional. In this lesson, we will examine copper cabling, fiber optic cabling, and the transceivers that connect them to network equipment. Let us start with copper cabling. Copper cables use electrical signals to transmit data. The most common type of copper cable in networking is twisted pair cable. Twisted pair cable consists of pairs of insulated copper wires twisted together. The twisting reduces electromagnetic interference or EMI and crosstalk between the wire pairs. There are two main types, unshielded twisted pair or UTP and shielded twisted pair or STP. UTP is the most common type used in Ethernet networks. It is less expensive and easier to work with. STP includes additional shielding around the wire pairs to provide better protection against EMI. STP is used in environments with high levels of interference. Twisted pair cables are categorized based on their performance specifications. Category 5E or Cat5e supports speeds up to 1 gigabits per second at distances up to 100 meters. It is the minimum recommended category for modern networks. Category 6 or Cat6 supports speeds up to 10 gigabits per second at distances up to 55 meters and 1 gigabits per second at up to 100 meters. Category 6A supports 10 gigabits per second at the full 100-meter distance. Category 7 offers enhanced shielding and supports 10 gigabits per second at 100 meters. Category 8 supports speeds up to 25 to 40 gigabits per second at distances up to 30 meters and is primarily used in data center environments. The standard connector for twisted pair cable is the RJ45, which is an 8-pin connector. For the exam, you should also know that RJ11 connectors are used for telephone lines and have 6 pins. There are two wiring standards for Ethernet cables, T568A and T568B. A straight-through cable uses the same standard on both ends and is used to connect different types of devices, like a computer to a switch. A crossover cable uses T568A on one end and T568B on the other, and is used to connect similar devices, like switch to switch. However, most modern devices support Auto MDIX, which automatically detects and adjusts for the cable type. Coaxial cable, or coax, is another type of copper cable. It consists of a central conductor surrounded by an insulating layer, a braided metal shield, and an outer jacket. Coaxial cable is used for cable television, cable internet, and some legacy network installations. Common connector types include F-type connectors used for cable TV and BNC connectors used in some legacy networks. Now let us move to fiber optic cabling. Fiber optic cables transmit data using pulses of light rather than electrical signals. This gives fiber several advantages over copper, including much greater distances, higher bandwidth, immunity to electromagnetic interference, and increased security since fiber is very difficult to tap. There are two types of fiber optic cable, single mode and multimode. Single mode fiber, or SMF, has a very small core diameter, typically 8 to 10 microns. It uses a single ray of light, typically from a laser, to transmit data. Single mode fiber supports extremely long distances, up to 40 kilometers or more, and very high bandwidth. It is more expensive than multimode and is typically used for long distance and high-speed backbone connections. Multimode fiber, or MMF, has a larger core diameter, typically 50 or 62.5 microns. It uses multiple rays of light simultaneously, typically from an LED. Multimode fiber supports shorter distances, generally up to 550 meters for 10 gigabits per second, but is less expensive than single mode. It is commonly used for connections within buildings, like between floors or between rooms in a data center. Fiber optic connectors come in several types. The SC connector, or subscriber connector, uses a push-pull mechanism and has a square shape. The LC connector, or lucent connector, is a smaller form factor that uses a latching mechanism. LC connectors are very popular in modern deployments. The ST connector, or straight tip, uses a bayonet-style twist-lock mechanism. The MTRJ, or mechanical transfer register jack, is a small form factor duplex connector. Understanding the difference between single mode and multimode is critical for the exam. A quick way to remember: single mode equals longer distance and smaller core, while multimode equals shorter distance and larger core. Now let us discuss transceivers. A transceiver is a device that both transmits and receives data. In networking, transceivers are modular components that plug into network equipment and convert electrical signals to optical signals and vice versa. SFP, or small form factor pluggable, transceivers support speeds up to 1 gigabits per second. They are hot swappable, meaning they can be inserted or removed without powering down the device. SFP plus transceivers support speeds up to 10 gigabits per second. They are physically similar to SFP, but support higher data rates. QSFP, or quad, small form factor pluggable. Transceivers support speeds up to 40 gigabits per second by using 4 channels. QSFP Plus supports speeds up to 40 gigabits per second with improved capabilities. QSFP 28 supports speeds up to 100 gigabits per second and is commonly used in data center environments. These transceiver modules allow network equipment to be flexible. Instead of having fixed port types, a switch or router can use different transceivers to support copper or fiber connections at various speeds. Let us also briefly discuss Power over Ethernet, or PoE. PoE allows electrical power to be delivered over standard Ethernet cables alongside data. This eliminates the need for separate power supplies for devices like wireless access points, IP cameras, and voice over IP phones. The two main PoE standards are 802.3AF, which provides up to 15.4 watts, and 802.3AT, also known as PoE+, which provides up to 30 watts. There is also 802.3BT, or PoE++, which provides up to 60 to 100 watts for higher powered devices. Let us review. Copper cabling includes twisted pair categories Cat5e through Cat8 and coaxial cable. Fiber optic cabling comes in single mode for long distances and multi-mode for shorter distances. Transceivers like SFP, SFP+, and QSFP provide flexible connectivity options. PoE delivers power over Ethernet cables. For the exam, focus on knowing the cable categories, their speeds and distances, the difference between single mode and multi-mode fiber, and the various transceiver types. Thank you for watching this lesson on Objective 1.5. In the next video, we will cover Objective 1.6 on network topologies, architectures, and types.